Hi class, the last video I gave you was on 10.1 and 10.2, and in it I talked about confidence intervals and how they relate to hypothesis testing, and I gave you something that was a little erroneous. It's true sometimes, sometimes it's not, and I want to dive into it. So let's look at hypothesis tests versus confidence intervals. And the problem I used last time was on banning cell phone use. And the given proportion, I'm just recapping it, was 0.5. I'm going to change the results of the survey though. Survey says 527 out of 1,000 agree. And this was our H naught. Recall H naught is our statement of equality. The researcher said it was higher. So our HA was P is greater than 0.5. We had alpha was equal to 0.05. And this would lead to a confidence interval of 95%. And I want to just show what happens when we do this. So we had stats, proportion stats with summary. And this time we have 527 successes out of 1,000. Oops. And we got p-value was 0.0439 now. That's still less than alpha. We reject H naught, which means P equals 0.5 should be outside our confidence interval. Let's take a look. I didn't want that. Portion stats, one sample with summary. 527, 1,000. We're doing confidence interval. So we should be rejecting H naught. P 0.5 should be outside of our region. Using StatCrunch, stats, proportion stats, one sample with summary, 95% confidence interval, which corresponds to 1 minus alpha times 100%. It gives us a region, the lower limit and upper limit, 0.496 and 0.558. P equals 0.5 falls inside 95% CI. This says we shouldn't reject. We just got done doing our hypothesis test though, and it said rejecting. What's the discrepancy? So, let's look at this as a normal bell curve. Normally, the 95% CI is this. This says P is not equal to 0.5. Our example, though, had the 5% all on the right side. The 95% CI has 2.5% over here and 2.5% over here. How can we modify our confidence interval so that it should match? So this is the idea. The 1 minus the confidence interval where we had 1 minus alpha is times 100%. This is when HA has the not equal sign. This is called a two-tailed test. And it has to do with the thing we had up here. One tail over here, one tail over there. So P not equal to has two tails. What changes with the one-tailed test? The left-tailed and right-tailed tests. So the left-tailed test this is when we have the less than symbol. Looks like an arrow pointing left. Here, if we have our alpha is 0.05, we're saying 5% is over here. Okay? The CI tab, though, requires two tails. We need to pretend there is 5% over here. Okay? That way to use the CI. What does that leave left in the middle? There's 5% over here, 5% over here, 90% in the middle. I'm going to go through and do this, but the other test is the right-tailed test. Let's just look at it real quick. And it has the greater than symbol. For HA. And it looks like an arrowhead pointed right. And so the names kind of come from the tails. Names of the tails come from which side is on. In terms of our normal distribution, now the 5% is over here. To use CI, we need 5% on the left also. Because it's symmetric, which also leaves 90% in the middle. The end result of this is, for a two-tailed test, the CI you want to use 1 minus alpha times 100%. For left or right-tailed, you actually want to double alpha. We had 5% here, we're going to double it, 10%. 1 minus 2 times alpha times 100%. So notice how I had it showed where it was showing inside. This said don't reject it because I had the wrong interval. Put that back up. The hypothesis test said reject it. The confidence interval using 95% said don't reject it. And the reason why is I had the wrong confidence interval in. I need to make it this. We had alpha equals 0.05. So CI, we're going to use 1 minus 2 times 0.05 times 100, which is 1 minus 0.1 times 100, or 90%. Let's look at our confidence interval with a 90%. And now look what happens. Lower limit, 0.501. Upper limit, 0.552. And the original P is out here. I've been using P. This was also mu of P hat. So this is technically mu up here, and mu plus 2 sigma, and mu minus 2 sigma. And now this supports rejecting it. So to wrap this up, if you want to link in summary, if you want to show how a confidence interval supports the hypothesis test, or vice versa, the hypothesis test supports the confidence interval. We have two outcomes. A, the alternate hypothesis has a not equal to sign, or the CI 1 minus alpha times 100%. The other option is if HA has less than or greater than sign, or the CI 1 minus 2 alpha times 100%. So if here alpha equals 0.05, the CI is 95%. Here, if alpha equals 0.05, the CI ends up being 90%. Okay. That should clear it up. If you have any questions, email me, but that's how the confidence intervals relate to the hypothesis test. It very much matters on which symbol's being used, and it has to do with that normal distribution and what regions, what percentages we're looking at on the outside. Is the 5% split over both sides? That's how the confidence interval works. If the 5% is just on this side, we need to simulate 5% over here for our confidence interval. And if the confidence interval, not 5% is on this side, we have to simulate 5% over here. So it doubles it. Okay. Until next time, 10.3 will be on parameter of a mean. Until then, peace.